All right, good afternoon, everybody. Thanks for making the time. This is our faculty seminar series, and we're starting it off with today's talk, and it'll go throughout the next few months, and we'll announce the talks as they get settled. My name is Nazim Chichek. I'm the Associate Dean Research for the Faculty of Agriculture and Food Sciences, and it's my pleasure to introduce today's speaker to you. But before I do that, just keep in mind that this will be available, this particular talk, on our YouTube channel. If you have friends or colleagues that couldn't attend today, make them aware of it so that maybe they can see it later on. Also, keep your eye on our social media for the next events that we might be hosting around this seminar or otherwise. Right? So, okay, let me get going. Today's speaker is Dr. Qiang Zhang. He's a professor in the Department of Biosystems Engineering here at the University of Manitoba, and a registered professional engineer in the province of Manitoba. Qiang completed his Bachelor's of Science in Mechanical Engineering at Hefei University of Technology in China in 1982, and his MSc and PhD in Agricultural Engineering at Penn State University in 1985 and 87, respectively. Qiang then joined the University of Manitoba as a research associate in 1988 and became an assistant professor, what was then called agricultural engineering, in 1989. He served as department head of Biosystems Engineering in between the years of 2000 and 2009, successfully transitioning that department from agricultural to Biosystems Engineering during that time. And then after that, he felt he could serve some more and became associate acting dean research for the faculty in 2010. For 1 year. Now, Qiang has been conducting research in the areas of agricultural structures and control systems, livestock environment, and digital agriculture. And on a personal note, Qiang chaired the search committee that hired me, so I'm eternally grateful. He was my department head for 9 years, and his mentorship to people like me, early career people, and right throughout the department was invaluable. So thank you, Qiang, and the floor is yours.
Well, thank you very much for the introduction. Awesome. We'll get the slides up and then. Yeah. That's good. Yeah. Okay. Maybe I'll start with this picture. I like this picture. It's very colorful. I guess probably tells the whole story with the digital agriculture, all this thing. And there's a little bit of story behind this thing here. When 2-3 weeks ago, when the dean's office, I guess Heather and Crystal asked me to provide a picture for the poster, I thought about it. I said, what pictures do I have? I used to draw pictures, and it looks like this. This is what I normally do. I teach a controlled environment course for animal systems. So every time I said, okay, you got a barn there, you got an animal there, how do you control the environment? So I always draw a little square as the barn, and I'd put the pigs in it. So you'll see this is a very engineering. So all you're looking at this picture here, the circles and the triangles, I put it all together. So then I thought about how do I get the picture? I thought, well, digital technology. So I went to ChatGPT, and I gave the whole bunch of conditions. Then I got that picture. If anybody wants to frame that picture, let me know. I send you a high-resolution copy of that picture. I don't think there's a copyright issue with the picture. This is the whole digital area. So the reason I want to start this one, it's basically, you'll see, the digital technology is everywhere now. It's affect your life. I don't know how many minutes you spend on your phone every day. And it does nice picture for me. And I'm worried if I ask this ChatGPT to design a barn, if it does a better drawing than mine, I think I'll be losing my job. So it is everywhere. So that leads to my topic for today's presentation. Bytes and Barns. And that's how digital technology are transforming livestock farming. I'd like to thank Crystal actually for suggesting this name. And it sounds like a digital. I actually would just put in the digital technology for livestock farming. But anyways, my focus here actually is more from the engineering perspective, from the technology perspective, how this digital technology is going to change the livestock farming. But people, I hope I'm not going to step on toes of those working in the animal area, like animal scientists. There's something probably I don't know a whole lot about, so I'll probably just go through it very quickly if I have to deal with the animals. So I'm going to focus on the technology, digital technology. Okay, here's a brief sort of outline for my presentation. I'm going to do an introduction. Two things I want to do in the introduction. I want to look at the characteristics of the modern livestock farming, because that probably justifies the use of the digital technology. Then I'll look into the digital revolution as something everybody's experiencing now, and probably is going to have more effect on us in the future. And then I'll switch to the digital technology and smart livestock farming. That's the main section I'll be presenting today. Then in that section, I'll do a framework of the smart livestock farming. Some is based on the literature, and some is just my vision or opinion. I guess whatever the way you want to put it. I want to sort of show you what might happen in the future, or what is already happening now. Okay. Then I'll go through some examples very quickly. Now there are some commercial technologies already available. People are probably think that's the digital technology. Yeah, it is digital. And the smart technology, I don't know. So I'm going to define all that. Okay. Then I'll talk a little bit about the challenges and opportunities in this whole area of digital livestock farming. Then I'll end my talk with a couple of concluding remarks. Okay, the modern livestock farming, it's actually very different. If you look at what we have now, what actually happened in, I don't know, 30, 40 years ago, is very different. There's two characteristics I want to bring it up. So I'm not going to talking about the animal aspect. I'm talking about the system, large scale, intensive, okay, and high degrees of automation. This is a picture I took a few years back when I was visiting an egg farmer. Looking at the picture, a lot of birds there, and on the left side, there's actually fancy controllers. That's the automation. It's the Maximus system. One thing sort of struck me at that point. I was talking to the farmer. He would just say, yeah, with so many birds and all those things you have to do, without the help of the automation, it's difficult. Life is busy. And then he said, well, with all this automation now, I can actually take a Christmas break now away from the farm. I can see what's going on in my barn. So that's the automation. Now, in terms of scale, you see this is a picture I grabbed from the internet. How many animals? I can't even count. So many. Very large scale, intensive, and intensive, and also automation in this milking system and the hog system. Okay, so large automation. It's all there already. What are the challenges now? Okay, I try to list a few things like from my perspective. And the number one problem when you talk to farmers, probably number one is the cost. The feed cost, labor, energy, water, all that stuff. And number two, I put it here, is the impact on the environment. So we have gone through quite a bit of this even within Manitoba. Like there's odor, the one I worked for many years. Then it's nutrients issues, all that. That's a challenge. Then this animal welfare becomes a big issue. So a few years ago, we started working on the loose housing for sows, and it's going to come back again. And then the disease management, I think currently it's a big issue for a lot of farmers. We'll be talking about PED, or from PRRS to PED. Then I guess people worry about the African swine fever now. So that's a big problem for farmers. Then there's the resource demand, water, energy. Probably for people in Manitoba, it's not a big issue, but globally, and the resource demand, actually, that's a big issue. The last one I put it here is the labor shortage. We probably don't see the problem here yet, but it'll come. So I was reading a report done by the Fraser Institute. They were talking about the projecting the labor force participation rate is actually, they predict a drop from 2019 to 2026, about probably 5% drop. So that actually, it's going to be a challenge to find actually people to work on the farm. Okay, so all that challenges are there. So if you are a hog farmer, could be any farmers, what do you want to achieve now if you still want farming? Okay, and how are you going to do it? I look at the answers I got from other people. Probably the first thing is I want highest productivity, best quality of pork, and least cost. And the bottom line is I want to make more money. I don't know if you're thinking that way. and also the least impact on the environment. Okay, there's probably other things you want to achieve, but this is probably the main things there. Then how are you going to do it? Well, probably from the animal point of view. So I want the best genetics, best environment, and best feeding strategy. And I want to know my pigs. That's very important. And the other thing is I want to know the market. Okay, it's not just what I produce. I want to see what is the market need there, and especially there's things you have to balance. For example, if the hog market drops and the feed price goes up, are you still want to actually feed the pigs, or how many pigs you want to feed, or you may have to change your feeding strategy, right? So to put all those things together becomes pretty complicated. You're going to have to really grab information from different places, and plus probably 3 PhD degrees to do it. You need a degree in animal science, maybe agriculture engineering, maybe veterinarian, or somewhere. You probably need about 3 degrees to do that, or even more. Okay. If you don't want to get 3 degrees, you go to the digital technology. Okay. So I want to show this picture again. You'll see with digital technology, you don't have to do a whole lot now as a farmer. That's probably the future. You still have to do quite a bit. So you can actually put different sensors on animals, sensors on like inside your barns. Then you can control things from your watch, from the computer. Then you can do things remotely. And even better, that's one of the things that will be defined with the smart farming system. You probably don't even have to talk to your sensor all the time. Those systems going to make decisions for you to combine all the stuff together. Okay, so let's look at the digital technology now. Like it or not, this is it's a revolution, the way I want to put it. Okay, it's basically from the farming point of view, we're moving from mechanical analog system to the digital technology. Okay, that includes internet and then mobile devices, social networks, and cloud computation. And lately, it's all artificial intelligence. The AI is going through the roof now. Everybody's predicting, the AI is going to replace this, it's going to replace that. Well, it's possible. We're still sort of in the transition stage. Okay, then it's changing everything. I said, if the ChatGPT can design a better barn, then I'll be losing my job. Well, the question here is, are you going to embrace the technology, or are you going to try to hide from it? If you don't do anything, you're going to be left behind. I guess you better probably just embrace it and move on and use the technology to your advantage. This is the point I try to get. So you cannot involve the digital revolutions here, and it's going to change the way we farm globally. Now, I like this the impact. I like this sort of a quote. The impact is going to be huge. I don't know, huge is just the words. I guess there's no really scales. If you want to compare, okay, and there's people actually calling this digital technology, the impact on agriculture is going to be another green revolution. The first one we probably all know, it started probably 40, 50, 60, or even goes to 70s. We developed irrigation technology. We improved the plant breeding and fertilizers. All that improves the yield of the crops. And the second one, it's not commonly widely recognized by people. That's actually the breeding and the genetics revolution. And if you're looking for sort of the second green revolution, may not find it there. There's some people think it happened already. So we are looking at another revolution. That's the third one here. That's the digital technology. Okay. Personally, I think this revolution is going to happen, or it is already happening. Okay. Now, there's often a question people always say, okay, yeah, the digital technology is here and it's going to affect us. But there's some people say, oh, I already been using this technology. Even some colleagues actually working in my field, they said, yeah, you measure the temperature and you put, yeah, I've been doing that for the last 50 years or 30 years. What is the big difference there? I'm going to probably sort of lead you through this thing. I hope my one of my purpose here today is to make sure everybody got that picture, digital automation, what are the difference? Okay, that's looking at the evolution from the lens of technology. So probably I'll go way back, like 1,000 or 15,000 BC, and what people still hunting. Technology used stones and bow and arrows, or maybe a stick. Okay, we're not going to get back that far. It's probably 10,000 years ago. And then we went to the domestication. So now the farming really started at that point. But there's a long way going to the modern farming. That's the one I'm interested in now. It's the mechanization and the automation. That's sort of the current, moving to the future. I think the next phase is the smart livestock farming, or I call it SLF. Now, what is the big difference between automation and the smart? I can give you an example. If I put a thermostat in the barn, I set the temperature, say 24 degrees, okay? And the heater will be turned on, automatic. Every time when the temperature gets below 25 degrees, it turns on, right? That's not smart. So if I actually put a smart system in the barn, I don't have to set the temperature. I tell the system to make my pigs comfortable, happy, done. So how the system is going to do it? We can use camera to take pictures of the pigs. We can record the sound of the pigs. We can look at the motion, how they move. We can put all that information together. Then that'll give the system enough information to make a decision. Oh, that temperature is a bit too hot, too warm. Let's turn it down. Or too cold and turn it up. Okay, that is considered to be a smart system. That's the difference between the automation and the smart system. Okay, so that hopefully that gives you some idea. Okay, so I'm going to actually define what is a smart system, like verbally now. Look at literature, there's actually different definitions of different things. This is one I sort of combined many different other definitions and also my understanding of the whole digital technology. And I'm going to read it to you, the important one. We're going to use the modern digital technology to assist or partially replace humans in managing farm operation. Not going to the details, just high level. And what is the purpose? The purpose is to increase the quality and the quality of the products and maximize or increase the animal welfare while optimize the resource utilization, like reducing the feed and labor and energy, and to minimize the impact on the environment. So that actually is my definition of smart livestock farming. And then we're going to talk about, okay, how do I achieve that? Well, before we get to that, I also want to talk about a few other things people often use. This is a term probably still used most in the industry or in the research community. It's called precision livestock farming. Okay, this one was, the concept was developed quite a few years ago. They're talking about precisely how to monitor animal, how to manage an animal. Okay, so I got two definitions here. One is actually from a researcher, colleague I sort of know for quite a few years. He is considered to be the virtual father of the precision livestock farming. That's Daniel Berkman. He actually did a presentation in July, online presentation to our forum there. But anyway, so that's his definition there. You can read it. And the next one sort of interesting is from a company. It's a Fancom. It's a European company. They actually manufacture quite a bit sort of smart equipment now. And they basically say, okay, the precision livestock farming is just a collective name for a suite of technologies that we use around animals in the house, and to continuously monitor the body conditions. Yeah, okay, they got a little covered there. So it's basically you use technology to monitor things, right? Could be controlling things here. Then if you're looking at actually another definition people might go to most often is the Wikipedia definition. And they're also talking about, monitoring animals, but they are talking about, because the word precision was used there, they're talking about monitoring every animal. And you try to actually control the environment or control the conditions control the feeding of every animal. But I think that the key thing here, the smart thing is to put all the information together to allow the system to make independent decisions. Like basically that's the definition of the smartness. And whatever the system uses will have to be able to make independent decisions. You don't have to set something there, the system follows it. Okay? Okay, the benefit of using this SLF, there's quite a few of them. I'm going to probably just go through it quickly. The one is obviously increase the production efficiency, improving the productivity, reduce the cost, which I already talked about, and minimize the environment footprint, and enhance animal welfare and health. And next one, I guess I should be talking about it. Currently, it's elevating farmers' workload. This is something farmers can take holidays during the Christmas break with the system. Okay. Then the bottom line here is to increase the economic return of farming. And I also put one line down there. Those are the things most of them are probably tangible, but there's also lots of intangible benefits, which probably people haven't thought about yet. For example, it's added value to the whole supply chain. It's not just the farmers. It goes to the meat products for processing and goes to the consumers. This actually, say if consumers are interested in traceability, the smart livestock farming is a good place to start. You got all the sensors there. You have all the information. You can provide all the information, and it'll be very transparent. How the pigs are raised. All that information is there. There's a study done in Europe. They actually were looking at the consumers' perception precision livestock farming or smart livestock farming. And it's very positive. If you tell people what you try to do, the consumer says, this is good. And that's going to, everything is going to become more transparent because I can look at the data. But that's another issue we're talking about, the challenge. Who owns the data? Then the consumer say, okay, this technology would improve the animal welfare and improve the transparency. That's actually very positive about it. So that's something that's probably intangible. It's the positive perception of the consumers. Okay. Okay. So now we'll get into the technical details now. Okay. So that's all good. So what is really the heart of the smart livestock farming? I'm going to sort of go through quickly with the sort of the components there. The first most important component, or not most, the first component here in the smart livestock farming is the information gathering. We call it sensing, use sensors. And the second piece is the communication and data transfer. Once you collect the data, you're going to transmit somewhere. The third one is the big one, is data and information processing, integration, and interpretation. Okay, then it becomes something people can use to either make a decision. Farmers could use the information to make decisions, and also it could be sent actually to automatic control system for action. Like, if the too high, simply turn it down. Okay, now that's the overall boxes here. If I actually looking at the engineering from the engineering point of view, what do I need to get that now? Okay, well, you need the sensors to collect the information. Okay, you need networks to actually transfer data. Okay, then you need data analytics like artificial intelligence to process data. Okay, after all that is done, you either send the information or control or commands to equipment for control, for automatic control, or you can send that information to humans for making decisions. Okay, so that's the framework. I'm going to show you an example in the pig barn. Now this is a bit busy, but it'll get even busier. Basically, what you have here, you got a pig barn here, you got a pigs here, right? Okay, so you got different sensors here. measuring the temperature, the camera here, or the sound microphones here to record the sound, then the infrared camera to measure the body temperature of the pigs. Okay, all those are the sensors. They all been set into a therapeutic model. Then the model is going to analyze all the information, then send the information to the control. If something needs to be changed, it'll send it there. So you turn on the heating system, or reduce the feeding, okay, and or change the ventilation rate, okay, or send a alarm or warning to a cell phone of the farmer, okay. So this picture probably was drawn quite a few years back. I think we can actually do more than this. If I take the picture, I'm going to give you this specific. This is the real smart system now. Okay, all the stuff is there. What I did is I added stuff there. First thing I added here, it's an information hub. This is actually the heart of the whole smart livestock farming system. You could either have this thing in the cloud, or you could have an edge computer, just the computer sits on your farm. So it's basically you're going to store all the data coming from different sources, then process data, then interpret data, then make decisions, okay? So what data we can collect? Well, lot, okay? You can actually looking at the air index when the air is going in there. Let's see if you got a biosensor there, you can actually detect the pathogens in it. Then that's going to warn the farmer, oh, you got some disease pathogens coming through your ventilation. So that data can be collected. And you can also monitor what's coming out from your ventilation. Like this is the outlet, you can actually collect, ammonia concentration, dust concentration, odor level, or even pathogens if you got any infections in your barn. That all go into the data, the hub. Okay. Then you can collect the information sensors in the manure, maybe some health markers or nutrient concentration, or even the antibiotic residues there. So that all go into your system, okay? And then you can actually collect the feed information, how much feed is left in the barn, and how much water I've been using, okay? So then you can also pull the information from outside, not from the sensors, like market, feed cost and commodity cost, all that. And the weather forecast, or even the disease surveillance information, all that can be going in there. So with all that information now, you can actually make decisions now. Okay, let's see if you detect something in a manure, then you say, oh, maybe there's a disease issue there. So you can either make a decision, or you can send the information to the outside, like send to the vet, or if your bin is empty now, or close to empty, so you predict there's going to be 2 more days left, you call the system's going to call their feed supply, say, hey, send me more feed. Okay, all the information can go to the farmer. The farmer can make the decision. So this actually is a sort of picture of the smart livestock farming system. Okay, so I'm going to go into more even details now, but quickly. And first, that big piece on the top of my chart is the information gathering, okay, using sensors. We can actually collect a lot of information. I sort of listed here from animal. You can look at animal behavior, motion, sound, posture, all that. You can also look at the health information, the body temperature, or different biomarkers, or even feed and water consumption, or the movement, sound, all that can be collected. Okay. Then you also can actually collect the product information. For example, for milk production, you can actually put a sensor in they're already doing that. Sensor in the milk pipe, then you can actually tell if the milk has got a problem. That actually can go back to the animal health. Okay. Then for the environment, we can actually measure temperature, humidity, air movement, all that, the air quality, dust level, gases, and pathogens, all that. And then the other sensors, normally those don't stay in the barns. We can actually look at the manure and the soil. So we can make this whole thing actually all connected. Okay. And there's also the sources not from the sensors, like the weather forecast and then the disease surveillance information can all go into my smart system. Okay, then the market information. Then there's something we call the soft sensors. So this is basically your software actually to predict or compute quantities that could not be measured or doesn't need to be measured. So we'll put all those things together. Okay, now this is probably a piece of information people might be interested in if you're doing research in this area. What are the sensors actually people are using now? This was a survey done a few years ago, and you'll see there's a different sensors, the body temperature all the way down to camera. Which one's actually used most is the camera. So that also is my prediction. The camera probably going to be mostly used. because camera can do a lot of things. You can measure the movement. You can look at the how they lie on the floor. The difficulty with the camera is, well, you don't have to touch the animal when you collect all that information. But the difficulty with the camera is you have to spend a lot of computation time to actually sort through the images on that. That's a challenging part. But people are still going after camera. Okay, data communication. Just very quickly, and you either have wired system or wireless system. I'm predicting the wireless system, it's going to be replacing the wired system. So we can start with the Wi-Fi and cellular, 3G. Maybe it's going to be done. Maybe 5G or 6G in the future. Then there's the Bluetooth. And then there's RFID, which is actually commonly used now in the animal industry for identification, like little tag on the cow, on the pig. That actually is the RFID. Then there's another whole set of sensors. It's called the low power wide area network, and those are the ones that actually transmit information a long distance. Requires very little power. So when you're looking at the network, there's two things you have to consider. One is how much information you need to transmit through the network. If you're looking at images a lot, you better go with Wi-Fi or cellular. And if you only take temperature reading every 15 minutes, you don't need that power because your bandwidth requirement is very minimal. So you better probably use LoRa and the low power long distance range, because you put a battery in it, it probably lasts 5 to 10 years. And you just collect data and transmit up to about 10 kilometers. So those are the things you have to consider when you're actually looking at the wireless networks. Okay, the next largest piece here is the whole data processing. Okay, this is actually got the sensors. You transmit it to the cloud or server now. Now you have to process the data. The general goal is it's actually you got a condition you want to monitor, right? Either environment or the animal. There's something there you want to monitor. Okay, so you use sensors to collect the data. Once you got the data, you have to combine them and distill it into information. Okay, from the information, you're going to further process it, combine it into the intelligence. Intelligence is the one actually drives the decision. Because this is the whole information theory. If anybody's interested, we can talk about it. I can probably give you a lot more details. But this is the process. Grab data, come up with the information, and to the intelligence, then you can come up with a decision. Okay. Now, how do you do that? There's a different tools, and the data analytics basically examines a large amount of data to uncover hidden patterns and correlations and other insight. And one of the probably most used tool in the future would be AI, machine learning. We still do a little bit of statistical analysis once in a while. And also you can do the modeling, which we've been doing for many, many years. That's still part of the system. We're not going to get rid of it. Okay, you can develop models. I'm going to give you examples later on. And the other one is data fusion. You combine different data together. This problem is driven by the autonomous vehicle. They actually do a lot of data fusion, try to make sure the car can drive by combining different information, different sources of information together. Okay, so that's the framework of the smart livestock farming. So I'm going to give you a few examples now to sort of go through this one to see how it works. I'll do the picks from the feeding to drinking and the weight estimation and the environment control based on animal behavior. And then I'll give you one specific example on the commercial unit. That's the cough sound monitoring for respiratory distress. And the other research piece is the motion analysis for disease warning, like that's African swine fever. Okay. Also, I'm going to give you a couple of examples on cows. We'll be very quick, and then the poultry. Then I'll spend some time talking about the example of the future technology. That's the digital twin technology. Okay, feeding. ESF, the electronic sow feeding system, has been used widely. For this one's good for loose housing for sows. Now, this actually it's automation. It's not a smart system yet, okay? Because it collects the information. You put in the information into the system. Okay, this sow is going to eat this much. and the sow goes in there, then the feed drops, then the sow eats, then gets out. So that's sort of automated system. This can be easily turned into a smart system. Okay, you can collect the data there. When sow goes in there, you can actually figure out how much she actually eats and how long it takes her to eat. Then we can put a weight station there to actually figure out how much weight they have. You do this every day, then you collect a lot of data, right? And we could add sensors there. For example, you could put a camera there, to look at the whole body and then maybe do a body condition score. You can put all that information together, and then you send it to a smart system to data analysis. You can turn this one into a smart system quickly. Okay, and this is sort of research system, and you can actually use camera to monitor drinking behavior. We're talking about drinking behavior, not just how much they drink, how often they drink, and then all that stuff. You can actually use a camera to do take the pictures and then process the information. And this is a research unit, so they actually are comparing this one with the water flow measurement, and basically you'll see if the imaging actually works well or not. Okay, then the weight estimate. This one does not need touching the animal. It's basically a camera takes a picture, then based on the 2D image, you can actually do the 3Ds. Now, this is one of the older sort of research projects. You can actually estimate the weight of the pigs just by looking at the pictures. Okay, and so this actually is a commercial unit you can buy. It's from Fancom. See the system actually is just a little camera here, but most of the stuff actually is in the software. So if you're thinking about the smart system, what hardware or sensors is the camera, and most of stuff actually is in the software. Okay, this cough sound monitoring, and it's pretty simple. You basically have a microphone there, and to collect the sound and the monitor, then to analyze. Now you can actually do a lot of things with the sound system. It's also a commercial unit. Okay, if you're looking at the microphones right there, you record the sound. There's a lot of data analysis goes on there. If you've been to the barn, you know how noisy the barn is. How do you separate the coughing sound from other sound? And even the coughing sound, during the COVID, people actually study COVID coughing sound. It's different from the regular flu. And you can actually looking at the sound pictures and to actually identify that. But for pigs, they actually developed this product already. What this can do for farmers, it actually can detect the infection earlier than the vet can. Okay, you put the system in because it's 24 hours a day all the time. So if there's any abnormal sound, they actually record it, then you can actually detect it early, then you can intervene earlier. So then that means actually it's going to recovery period is actually much shorter. That means that can translate into monies, I guess, for farmers, less loss and better return. Okay, the system is commercially available now. Okay, then the other is a piece of research people have been doing, try to use the motion analysis for African swine fever. And this is also based on camera. You take the image, then you're looking at the movement of pigs. Now, the actual system is a lot more complicated. The pigs moves a lot, and you'll see a lot of random movements there. But anyway, after some data processing, what they find out is they actually artificially infected the pigs on the day 11. You'll see the activity level start to change. The top line is they call the base activity, like those are baseline activity. Those are pigs that move and they go to eat and all that, regular thing. Okay, then the bottom line, the second line here is actually the animal movement. And they want to just do something, not actually eating and just want to do something. Then the bottom line actually is the movement due to the human interference. If you walk into the barn, they'll move, right? They separate them, then you'll see from here, the base one actually increases a lot. I mean, pigs not doing additional things. They actually just lie down and rest a lot more. And the animal, the other type of activity actually decreases. That means pigs are going to move less once the infection. So this actually can help you. Very simple system, just a camera. You can actually have a very early, quick detect of the onset of the African swine fever. Okay. From the control the environment point of view, so we're talking about the animal sensing, then the environment control, I use an example, set the temperature 24 degrees, or you talk to animals and ask them if they're happy or not. That's what we do, right? If we feel cold, we just go there to turn up the thermostat. But the animal don't know how to do that. We have to rely on a smart system. Okay, so this is sort of the base here. When the animal is having problem with the environment, they'll tell you. And that's if they get too cold, they'll huddle and pile up. And all chickens are gonna, move the wings around the body because it gets too hot. There's a lot of animal scientists here. You probably can tell me this is true. Okay, how about if you just take a picture instead of set the temperature? You actually use image here to actually control the temperature. This is a study I sort of involved way back when I was on sabbatical at Iowa State, and they basically used one camera to take pictures of pigs. You'll see one is pigs are sleep close together, the other one is spread out. So the one on the right there is telling you it's too warm for them. They don't want to get together because pigs normally are social animals. They want to get close to each other. But if it gets too cold and too warm, no, they want to move away. So you can use that to actually control the temperature. This is one of the projects I did when I was on sabbatical at Iowa. It's actually for little pigs. We use infrared camera. So it actually tells you the surface temperature of the pigs. You can use that information to control the environmental temperature, right? Okay. The system used for that example. This is an example of the milking system for dairy farm, and very commonly used now. It's sort of going to the smart direction now because you get actually collect all the information when you actually put the cow in the milking sort of a cage. Well, not the parlor anymore. You actually collect the information on milk quality. You also feed the animal there. You also take the measurements of different things. You can actually measure the weight of the cow and the time they spend there. All that information. You can put all that information together. Fit into your data analytics and to analyze if this cow it's perfect, works well, or if there's any issues. Okay, this can sort of get into the smart system now. Okay, then experimental study. Just use a simple accelerometer. You can actually monitor the activities of cows, and like even outside. This is actually on the pasture. Okay, you can look in at the grazing time, the walking time, and the ruminating time, and all that information can be collected. Now, how do you use this information? That's still a big challenge there. You're going to have to develop your data analytics to actually to do that. Okay, and the next example is the poultry feeding system. It's basically measure the sound when birds eating, then they'll make a sound. You can actually analyze the sound and find out how much they eat, how long they actually been eating. So that's sort of simplest solution. And this is a commercial system actually for a large range operation. If chickens actually stays on the floor, you don't see the individual bird here. What you see is just a dot. Now, can this help you? Yes. If you're looking at distribution pattern, and if one of the feeder actually is out of commission, or one of drinker is out of commission, you'll see that pattern change. Birds all move away from that area. It's not something you have to go in there because you just see the picture. Oh yeah, this is not normal distribution. Then you go in there, you'll find the problem. Okay. So the last example I want to talk about here is the future of the digital twin. I like this technology. I think it's going to have a huge application. It's a digital twin is just a digital mirroring of a physical system. It's sort of like cyber-physical fusion. Okay, and people always say, "Oh, is this the same as my model?" Try to predict it. No, it's not. You could have a model built in a digital twin, and the most important thing here, you actually have a bi-directional data flow and intelligence feedback. So your digital twin talks to the real system real time. And that actually can verify if your digital twin is actually the same as your physical system. If it's not, use data to improve it, to modify it. Okay? So if you can imagine, if I actually have a digital twin for cows, then I know I don't have to go into the barn. I know every cow from my computer screen. Now that's going to take a lot of work. I'm telling you, this is just a picture. And yeah, the picture probably is, I don't know, you can consider that as the simplest digital twin. But if you want to really know the animal, you're going to have to put in different models in it, like the physiological model or physical model to put in it to actually make a true digital twin. This is the way I want to present it here. If you actually have a cow, you put sensors on the cow or in the cow, depends on the sensor. Could be wearable sensor, or could be pills they can swallow. And you can also have sensors for the environment. Okay, all that data goes into digital twin. Okay, what's in the digital twin? I have data, data processing, and from the environment and from the animal. Then I can have different model building. This model could be traditional model like physiological model, growth model or behavior model, and it could be just machine learning model, okay, like AI model, okay, and then I'll process the model. Then the algorithm will make the decision. I can use that to control the environment. If it's indoor, then that obviously the environment needs to be controlled. Okay, and also make decision for intervention. If anything happens, I can also take the data from other sources actually and put into my digital twin. An example, this is a project I worked with Dr. Laurie Connor quite a few years ago in looking at the sound, the lameness of sound. How do you detect it? And we didn't go very far to the digital twin, but that project's done already. But I'm thinking about actually develop a digital twin, use this information. So basically, we actually develop a 2-dimensional stick model to simulate the movement of a cow. Sorry, a sow. And so that could be the speed of the movement. It could be actually the back angle. The whole thing can be simulated here. Okay. Then what we can do, we can actually put marks on a sow and take pictures. Or we can develop an even better system. Without the marks, we can still get pictures, videos of the sound, right? So based on that, we can actually look at the movement. So what we're going to do, we can actually compare, what's in the model and what has been measured. And then if the model said they have to walk in this speed and the feet will have to swing this way, and I said, okay, it's not doing that. So maybe there's a lameness. We actually did some comparison. The accuracy actually is pretty good. I'm looking at 92%. Okay, so that was the digital twin for a single pig. So then I said, okay, maybe we can do the digital twin for the whole barn. Yes, people are thinking about this. Actually, I did not generate this one. Looks like this was the ChatGPT generated picture with the same source. And this actually is a demonstration of the digital twin for the whole barn. So you got a digital twin for all the animals. They have a lot of twins there. Then you also have a twin of the twins of the systems, like the ventilation system, monitoring temperature. You can put all this thing together. That's going to be a huge project. But I think in the future, we'll have all those things together. Okay, so in the future, what are the challenges there? Yeah, sensing is one of the big things there, and we're looking at animal behavior and what parameters it needs to be sensed. The other thing is the tracking of the moving animal. It's very challenging. Okay, then animal health, which still, animal scientists probably should figure that out. And what are the biologic parameters needs to be sensed? Okay, and the biomarkers, all that. And the environment I already talked about. You listen to animal, you observe animal. And one of the challenges here is the sensor reliability. We don't have the good sensors yet. The other challenge is compatibility. You buy sensors from different sources, they don't talk to each other. So we ran into that problem with our smart vertical farming system with plants. You buy a sensor from here, they don't talk to that sensor, doesn't talk to your server. So that's a challenge there. And data processing, I think that's the key research area. Big data analysis is not that easy. And from the barn, the noise is the big problem. And the speed for real-time monitoring, images, requires a lot of bandwidth. Okay, then the high-quality data set for training the AI system. Everybody's been talking about AI. If you don't have a good quality training data set, your AI is useless. So this is actually what we need to do to overcome that hurdle. And the other thing actually is the data ownership. We still try to figure out who owns the data if you actually put all the sensors on a farm. Europeans sort of started this process. I guess we probably will start this one soon. And the other big thing here is, okay, now we got all this technology done. how can you convince farmers to buy them? And that's a big problem. There's a couple of issues there. High initial cost is a problem, and the data ownership is a problem. I think the most important thing is there's not enough information that farmers could use actually to see the benefit of using the system. They say, okay, I invest so much money, what do I get out of it? There's not enough information there for farmers to buy in. Okay, so in concluding, Marks, I want to bring 2 points here. One is with the rapid advancement in digital technology, the smart livestock farming is emerging as a powerful tool to assist or partially replace farmers in managing farm operations. The whole smart livestock farming is still in its infancy. That's the way I looked at it. But it will revolutionize livestock farming in terms of increasing efficiency and productivity, improved animal welfare, reducing resource requirement, and minimize the impact to the environment. It's got a very bright future there. And that requires people to work together. So one discipline is not enough. We need people, animal scientists, veterinarians, and engineers, computer scientists, and even social science, that we have to work together to actually develop the system. With that, I thank you for your attention.